What's up, guys? Welcome to Q&A Mondays. I'm Thad Barnette. Today we're continuing our series about wind and wind uplifts in regards to metal roofing. Check out the first two episodes in this series if you haven't seen them already. Today we're looking at ASCE 7, what that means in regards to wind uplifts and engineering. Today I've got Jeff Hock from the Sheffield Metals Technical department. Thanks for being here, Jeff.
Absolutely. Happy to be here.
So what is this ASCE 7? What are we going to be talking about today?
ASCE 7, ASCE is American Society of Civil Engineers. It is basically the standard for determining design loads. There's different versions of ASCE 7, ASCE 712, ASCE 716. Basically, anytime there's changes in the code or requirements, they come out with a new version of ASCE 7. So depending on which code your project is requiring will also determine which version of ASCE 7 you're using. But it's basically a way to figure out design loads for your project. And it's the standard that's used pretty much everywhere.
Where is that in relation to local building codes? Does it set the standard? Do the local codes set the standard? What does that look like?
So for commercial projects, it's going to be the standard that's what's used, and it's the most available and accepted version to figure out basically what type of pressures your roof's going to have to meet. As we're going to talk about, there's a lot of things that affect building design. There's not one set of set answers for every building. So it's going to help basically give you job-specific calculations for the particular project that you're working on, and it's going to keep you safe, right? Because you're going to know based on this program exactly what your building's going to, expected to have to go through. And once you have that information, you can design it properly and use the right components and pieces to, make sure you meet the criteria that is going to be required.
So in this video, we're going to be talking about some of the different criteria that adds up to create those final job-specific calculations to meet the ASCE 7 requirements. So first, let's talk about roof zones. This is something that is one of those pieces to the puzzle. So Jeff, what are roof zones and why do they matter?
You have at least, there might be more, but you have at least 3 different zones of your roof. You have your corner zones, which are basically the outside edges of your roof. You have your perimeters, which is basically any edge. It could be an eave, it could be a rake, it could be a ridge. And then you have what they call the field area. And the field is basically the inside portion of the roof section. If you are looking at a typical square, your corners are going to be zones 3. Your perimeters are going to be zones 2, and then inside of those zones is going to be zone 1, which is your field. They matter because, as we talked about in an earlier series, winds affect different parts of your roof at higher speeds, right? Your corners are going to take basically a double whammy from both sides when it comes to wind. So they're going to take the most force that the roof is going to see. Your perimeters are going to be the next highest areas that are going to see the most wind, and then the field is going to see the least amount of pressure. ASCE 7 is going to give you design calculations basically for different areas of your roof, right? Based on the different loads that it's going to receive. Zone 1 is going to be the lowest pressures that you're going to need, and zone 3 is going to be the highest pressures that you're going to need.
Okay. And so that affects things like clip spacing?
Absolutely could affect clip spacing. I think we're going to talk about this a little later, but depending on the design pressures, not the ultimate pressures, but the design pressures, half of your ultimate load, if you have a panel that got really good uplift pressures and your project isn't requiring anything too stringent, you might be able to use one clip spacing across all areas of your roof. If you have higher design pressures that you need to meet, you might have to vary that clip spacing in different zones to meet the higher design pressures in the corners and the perimeters, and then you might go to a further spacing in the field area. It really depends on what criteria the roof's going to require and what the panel met as far as the designs it's able to achieve. With all that being said, that's exactly why this is important, right? It's not just I have it engineered so I can use this clip spacing everywhere. I have to have it engineered for this building per these conditions in this location.
So when we talk about ASCE 7, do we see that used in commercial projects mainly?
Yeah, I mean, it could be used in commercial or residential projects, but it's very heavily used in commercial projects. There's not just one set standard. Every building's going to be a little bit different. Every location that it's in is going to have different requirements. It's the cross between the testing from the manufacturer, the project that it's being used on. It brings those two together and how it should be used.
Let's take a closer look at design pressures. How do they relate to wind speed?
That's where the ASCE 7 comes in, right? A design pressure that for a building that's 10 feet off the ground is going to be completely different for a building, that same building, if the roof is 50 feet off the ground, right? Because you're getting different areas. But that's how these design pressures correlate into wind speeds, because you have to take all the factors that are loaded into ASCE 7 program, and it determines and it does the calculations based on, the wind speed that it's going to see for the location, the importance factor of the building, the exposure categories. It takes all these things into account, and that's what tells you these are the design pressures you're going to need to meet for this project.
So when we see like a specification from an architect, designer, what types of things do they call out? Do they include design pressures that need to be met? Do they include wind speed? How is that usually seen?
And the nice ones and the easy ones, they have, they'll have the ASCE 7 calculations done, and they'll usually put them right on the plans. They'll say, here's the different zones, here's the criteria that was, entered for, and here's the pressures you need to meet, zones 1, 2, 3. More often than not, you'll get in the specification, has to be engineered per ASCE 7. And then that's when you're going to have to go out, and the contractor or the GC is going to have to get their own calculations done based on, the building requirements. It's not very hard. Usually everything in the spec is going to talk about the different criteria that will be used to get the calculations done, but it'll be on the onus of the contractor or someone similar to go out and have the calculations performed. We have a couple engineering firms that we work with. They know exactly what when you say ASCE 7 wind load calcs, they know exactly what you're talking about. These companies have licenses in all 50 states. So, because that's the other thing, you're 99% of the time your calculations are going to have to be performed by a state licensed engineer where that project is.
So let's talk about those job specific calculations. If I'm a contractor, how do I do that? What are my first steps in getting those calculations done?
Well, the first thing is, to work with your manufacturer, right? Because your calculations need to be based off the testing you have available to you. If you're buying a Sheffield roof, you can't use somebody else's testing report because you're buying our material, right? So if you're using Sheffield Metals, basically you're going to know your panel profile. You're going to have your information on the job based off the plans and specs. And then we're going to help you work with a third-party company to basically get your calculations done. We're here for guidance and support. We try not to be the middleman because things don't always get relayed correctly in translation. So we try to just, set up the meeting, make sure you have all the information required from us as far as the testing, that you have the proper information. We can help you find it in the spec and plans, and then you work with the engineer at the company, and they'll basically give you calculations. There's not a whole lot that goes into it. It's not very hard. It's just, it's one of the things, if you're not familiar with, it might be a little confusing at first, but it's not very hard once you've done it a couple times.
If I'm bidding on a project and I'm taking this into account, and this might affect clip spacing, whatever, how do I accurately bid a project, but, without having those calculations already performed?
So again, if they're on the plans, that's the easiest way, because we have an engineering cheat sheet that basically lists all of our panel profiles, what the assemblies that they were tested with, and then the different design pressures for the different clip spacings, right? So if you know what you need to meet in zone 1, 2, and 3, you can review the engineering cheat sheet, match up what design pressures we have for the system and the assembly that you want to use. That makes it pretty easy, right? If they already have the calculations done, it's pretty much, okay, yes, we can meet it. The other option, if calculations aren't done and you're bidding a project, you probably don't want to go spend a bunch of money on calcs getting done if you haven't, won a project yet. We did a video before on our FVC approvals and how to convert design pressures into wind speeds. And while it is not calculations performed by an engineer, it should give you a halfway decent comfort level of whether or not the project you're looking at can be met with the design pressures that we can offer. You look at the chart, and we talk about it in the video. You talk about the mean height, the exposure category it's in, and those are pretty easy to figure out. We can talk about those, and the wind speed that you need to meet. and it'll give you a rough estimate as far as a design pressure. If you can meet those pressures well above with the panel systems that we have to offer, it's probably a pretty safe bet that, you'll be able to meet the design calcs when it's done. If it's right there on the edge, it's something to have a conversation about.
So we're throwing around a lot of language, about engineering and testing that the ASCE looks for when it comes to these job-specific calculations. So what else, what other criteria is included in that, whole package?
Yeah, so the main thing to know, I think, about ASCE 7 is that it's going to be job-specific calculations, right? Everything that it's going to take into account is specific to your project. It's a one-time thing. If you use it on this building, unless you have the same exact building right next door, you're probably going to have to get new calculations done if anything changes. So it's a one-time thing, even if there's not a requirement for it, right? It's a pretty small investment to have the calculations done. I'm always about, covering my six, making sure that there's no questions about things that are being done. This is a really good way to do that, residential or commercial. Like I said, it's not very expensive, especially when you consider the overall cost of a metal roof. It's very minimal. Having something that says this is exactly how your roof should go on, or the engineering on the panel that you have based on the design of the building that you're doing, it's pretty invaluable in the scheme of things. If I was a homeowner, or a building owner, it would absolutely be a requirement because, like I said, the cost is minimal and what you're getting out of it and from it. I hate to use the word peace of mind, but it's a lot of peace of mind.
All right, Jeff. Well, I really appreciate it. Thanks for the discussions today. If you have any questions about ASCE 7, comment down below and stay tuned for our next video where we'll look even deeper into building characteristics, wind speed maps in our final episode of the Uplift series. Thanks for watching. Subscribe here to the Metal Roofing channel. As always, I'm Thad Barnette. We'll catch you next time.